Alright, today we're going to solve another problem from the topic Newton's second law of motion, concept of a system. And this time we're going to solve the exercise 14, which says, suppose the mass of a fully loaded module in which astronauts take off from the moon is 10,000 kilograms. The thrust of its engines is 30,000 newtons. Calculate the magnitude of acceleration in a vertical takeoff from the moon. First we're going to work with part A and then we will go with part B. So let's go to the blackboard and there it is. Okay, the first thing that you have to do in this kind of exercises is identify all the forces involved. So the first force involved in this exercise is the force of the thrust of the engines, which is going upward. Besides, after the engines start working, there is going to be an acceleration, which is going to be upward too. This is very important because every force that is against that acceleration is going to be considered as positive. So don't forget that. Every force that is against this acceleration is going to be negative. Finally, there is another force here, and it's the weight of the module. But the thing is that we don't have this weight. Here it is, the weight. So, how can we do to calculate that weight? All right, there is a formula for the weight, which is quite easy. It is mass times the gravity, but here you need to know the value of the gravity on the moon, which is very easy to know because you can Google that. And let's see, the weight of the module on the moon is going to be the mass of the module, which is 10,000 kilograms. By the way, I wanted to put here Ft for force of the thrust. Alright, so forgive me about that. Okay, we have 10,000 kilograms multiplied by the value of the gravity on the moon, which is equal to 1.62 meters per squared seconds. All right, 1.62 meters per squared seconds. So the weight of the module, it is equal to 16,200 newtons. Don't forget that you have to multiply the numbers and also the units, and kilograms times meters per square seconds is equal to newtons. Now that we have this, what do we have to do with that weight and with the force? Okay, let's consider that we have two forces here that aren't perpendicular each other. We have an acceleration and we want to know the magnitude of we don't have the acceleration, we don't have it. We have the mass, but we don't have the acceleration. So let's consider that we have two forces. We have a mass and we need to know the acceleration. Well, I think that the most suitable formula that will work here, it will be the Newton's second law of motion. Since we have two forces, we have a mass, and we need to know the acceleration. So let's use that formula in order to get the acceleration. Here it is. The Newton's second law of motion states that the addition of all the forces is equal to the mass times the acceleration. So let's calculate all of that. What are the forces involved here? The force of the thrust, plus the negative of the weight, since the negative is going downward. Okay, don't forget that every force that is against the acceleration is going to be considered as negative. and that is equal to mass times the acceleration. Don't forget that our unknown is the acceleration, so we need to isolate it. And for that, we need to send that mass to the other side. And since it's multiplying here, it goes to the other side to divide the force of the thrust. And here we have negative multiplied by positive multiplied by negative is going to be negative. Force of the thrust minus the weight divided by the mass is going to be equal to the acceleration. Now let's replace all the data that we have here. The force of the thrust of the engines is equal to 30,000 newtons. Minus the weight, which is equal to 16,200 newtons. And all of that divided by the mass, which is equal to 10,000 kilograms. There we go. And that's equal to the acceleration that we want to know. Alright, 30,000 newtons minus 16,200 newtons is equal to 13,800 newtons. And all of that divided by 10,000 kilograms. Now we have a problem there. As you can see, the acceleration is measured in meters per squared seconds, but there aren't any meters per squared seconds in this exercise. So where are they? Okay, what we can do here is replace that Newton by kilograms times meters per squared seconds, like this. Okay, let me put it that big. Okay, let's see. Instead of newtons, I'm going to write kilograms times meters per squared seconds. And there they are, the meters per squared seconds that I need, because I'm going to cancel both kilograms, and what it remains is the meters per square seconds. 13,800 divided by 10,000 is equal to 1.38 meters per squared seconds. And that is equal to the acceleration that we are looking for. And there we have the acceleration of the module. It will be equal to 1.38 meters per squared seconds. Now part B, it says, could it lift it from Earth? If not, why not? If it could, calculate the magnitude of its acceleration. So what do we have to do here? Okay, here's the thing. Given the same force of thrust, we have to know if the model will be able to lift off from Earth. Would that be possible? Okay, let's see if it will be or not. Once again, let's try to identify all the forces involved in this exercise. First of all, we had a force of the thrust. Once again, it's going to be equal to 30,000 newtons, sorry, force of the thrust. Let's suppose that the acceleration is going upward, because, well, that's what we want, right? That the model goes upward. And don't forget that the weight is also important and involved in this exercise, because that liftoff should fight against the weight. Alright, once again, we don't have the value of the weight on Earth, but we can calculate that with the previous formula that we already used, which is the mass times the gravity. There we have it. But this time, the value of G is not going to be equal to 1.62. This time it's going to be equal to 9.8 because we're working on Earth. Okay, the mass is equal once again to 10,000 kilograms times the value of the gravity on Earth, which is equal to 9.8 meters per squared seconds. Once we multiply that, we will have the value of the weight. The weight is equal to 98,000 newtons. Don't forget that kilograms times meters per squared seconds is equal to newtons. There we have it, newtons. Alright, now we need to know if there is going to be a lift off. That means we need to know if there is going to be an acceleration and if there is going to be an upward acceleration. So let's see. Given the mass, given two forces, and we need to know the acceleration, which is going to be the suitable formula. Well, once again, it's going to be the Newton's second law of motion. Alright, so let's take it to this part of the exercise. Here it is. And once again, we have to add all the forces involved, that is, force of the thrust plus the negative of the weight equals to the mass times the acceleration. Okay, that was an awkward A. Now it looks better. Alright, and let's change all the values that we know. Let's replace all the data that we know. The force of the thrust, once again, is going to be 30,000 newtons. A positive multiplied by negative is going to be negative. The weight equal to 98,000 newtons. Oh, sorry about that. Equals. Oh, sorry about that. My bad. Okay, equals to 10,000 kilograms times the acceleration. Okay, it's time to subtract. 30,000 minus 98,000 is going to be 68,000 negative. 68,000 newtons. And since we're trying to isolate the acceleration, we can send that 10,000 kilograms from one side to the other from multiplying to divide. So here we're going to put 10,000 kilograms. Once again, I have the problem of the meters per squared second that I don't see. Nevertheless, I can replace that Newton by a kilogram times meters per square second. And there I will see the meters per square seconds that I need. Kilograms times meters per squared seconds. Alright, we can cancel both kilograms, and the result of that division, it will be minus 6.8 meters per squared seconds equals the acceleration. Now, what is the meaning of this negative sign? Well, that means that after all, that module won't lift off from Earth. Okay, if you remember in the previous part, the acceleration was positive, but here the acceleration is negative. So that means that after all, the acceleration wasn't pointed upward. Instead of that, it's pointed downward, okay? But what that doesn't mean at the end of all, it means that the module won't take off from Earth. So, well, that's it. That's the end of this exercise. I hope you could understand that exercise. Always remember, try to draw all the forces involved in the exercises, and hey, well, try to use the formula that you have to. Okay, well, don't forget to give me a thumbs up, and I'll see you in the next video. Goodbye.